Hi, this is Chris West from House Calls Vermont. Welcome to the House Calls Vermont live show on YouTube. As a part of our YouTube show, we're going to be doing interviews with people who are representatives of companies that are creating new products, interesting products, products that we're pushing or liking, and we'll tell you about what it is and why. And today we're speaking with Rob Conboy from Glavel. And so, welcome, Rob, to House Calls Vermont.
Yeah, thanks, Chris, for having me. Appreciate it.
Very happy to have you here. So, Glavel is a product, a new product on the market. It is a below grade insulative material that we're looking at replacing plastic materials like EPS and XPS, and some people even putting rock wool below grade, which I think personally is about as nuts as something can get because
Yeah,
it doesn't
yeah,
absorb water. No, nothing like that does absorb water.
yeah.
Um,
Or
uh,
invite pests, but yeah, exactly.
Exactly. All the various things about why we wouldn't want to use a woven spun material below grade.
Exactly.
So introduce me to Glavel. I know quite a bit about it, but you and I have been talking for the past couple of years.
Yeah,
So what is Glavel, and why should I care?
yeah. So foam glass gravel is a product that's been on the market in Europe for over 20, 25 years. Um, in my research of the product, I actually found an EPA report dated August 1977 that recommended that we convert our recycled glass, like Chittenden County solid waste glass, and turn it into the building material foam glass gravel, more than 40 years ago. So it's a product whose time has come. What's wonderful about bringing foam glass gravel to the U.S. and North America is that it's not a science experiment. We're standing on the shoulders of giants, European partners that have seen myriad of applications, including under footings and really leaning into the compressive strength properties of the product, issues like radon and how to put radon measures through the product. All of those things have been done over in Europe. So we're able to mitigate the adoption risk by working with our European partners on various use cases and how customers want to replace their nasty rigid foam board, as you mentioned, that comes with a ton of petroleum, ton of nasty chemicals that are pervasive in the environment, and we're burying this at an alarming rate underneath our buildings. And burying a product like foam glass gravel that doesn't have all those chemicals, it's naturally fire retardant, so you don't need to add those chemicals. It's obviously not petroleum based, so has an enormous amount of benefits, especially when we think about um, the broader sense of healthy homes, not just the environment within the home, but what the home is sitting on is critically important.
Yeah. So tell me a little bit about exactly what foam glass is. Like, uh,
Yeah,
I understand that it is a vitrified, and please, we can go into what that means. But you start off with used glass. How does something get from
yeah.
used
So
glass over to,
yeah,
yeah?
it starts with, like you said, it starts with recycled glass. We're going to be working with glass that's been cleaned to less than 1% non-glass, so paper or the off chance that there's plastic in the glass, and that gets ground into a fine powder, and that's kind of what the powder looks like. And that fine glass powder, to it you add a foaming agent. In our case, we're going to be adding glycerin, which basically, as the product rolls through a 25-meter long kiln at 15,
Wait, wait,
16 minutes.
wait, 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 wait. We don't say meters and then expect
Oh,
people to
I'm
know
sorry.
what we're saying. So
75
25,
foot, 80 foot. Yeah.
25 yards.
Yes. Yes. We have to, convert to imperial
Yeah,
units.
you're good. Go on.
Um, and at that temperature, basically the chemical reaction um, creates the bubbles, if you will, and the product starts out of, I almost said 2 centimeters, but it starts out about an inch or a little bit less than an inch, and then foams up about 4x. And by design, as the product leaves the kiln, there's a cooling table that allows it to rapidly cool down and fracture, creating these, random shaped aggregate, for lack of a better term, that then gets bagged up or bulk shipped to site.
So that's great. First of all, I also want to point out that this, unlike most of the building materials that we use in Vermont, you're building a factory here in Essex, Vermont.
We are.
So yeah, so this is going to be a locally produced product that you're hoping is going to be shipping all over the country and
yeah, exactly. And in order to minimize some of the risk of standing up that plant in Vermont, we have been working with our European partner to import product to get some demonstration projects launched here in Vermont. We have a project in Richmond that's coming up soon. And we will be doing demo days out at our plant once we have that product available from our European partner. So we'll be inviting out designers, excavators, developers to come out and play with the product and see how it actually functions. Because we are effectively removing the need for the gravel layer as drainage and the foam layer as the insulative layer. And replacing that with one product. And even before the current price increases of rigid foam board and the shock to the supply chain that occurred in February with the big freeze down in Texas, our product was at cost parity or a little bit cheaper depending on the size of the project in terms of the installed cost of foam glass versus the call it the traditional way of insulating below slab. So there's no green premium for what we're doing.
Right. What we're hoping with this product is that it's going to be a value added but not a cost added product, right?
Exactly.
And if it is truly a wash, then we're replacing stone, which is a quarried, a mined material, and we're taking the foam out of the entire waste stream. Never mind the fact that the most recent science is showing that microparticles of plastic are places where bacteria and other types of horrible things can grow in a way that we didn't know before. So when we're putting this plastic into the ground, what we're actually doing is loading our groundwater with microplastics for generations, right?
Exactly.
This is all just untested experiment we're doing on ourselves. So your product is something that takes a material, recycles a material, and produces what could be considered clean fill. Do I have that right?
Yeah, I would say that. I mean, we are definitely selling on the function of the product, not necessarily the form. But yeah, it's the value as an insulator. And in 2019, we committed to produce foam glass using renewable energy. So on top of the great story of taking glass that has little or no value and upcycling it into a valuable, useful building material, we're going to do it using renewable energy. So the result is an incredibly low embodied carbon building material as well.
So do me a favor, explain exactly how you're going to be doing with alternative energy, how you're going to be using renewable sources for that process. Because generally, just like with cement, if you have to raise something up to 1400 2000 degrees Celsius, you're using natural gas. So tell me a little about that.
Yeah, so we basically opted to spend a little bit more money on the kiln and electrify the process. So yeah, you're absolutely right. Most kilns are gas-fired. Most foam glass gravel kilns are gas-fired. There are electric kilns in use right now in Finland and other northern countries where they have a lot of cheap energy. So we opted to switch to electric and then make sure that we can keep a price point and a cost that makes sense. But we believe in the long run, that commitment to electrifying our production is going to be a huge benefit, not just to us and our operations, but also to our customers and the embodied carbon associated with their purchases.
This is exactly what we want concrete to be doing, right? We want to move away from you. I mean, there's nothing intrinsically wrong with concrete. The thing that's wrong with concrete is the amount of natural gas or other types of fossil fuels that are burned to keep that oven going for the, what is it, 3 to 5 days it takes to turn the base elements into Portland cement. So this is a great. I'm really glad that you went the extra yard here. Now, not extra meter,
no
but extra yard, yeah. to make sure that you can look your customers in the face and with a straight face yourself say, we went the extra distance to make sure that this is a net zero plant on at least the making of the Glavel side. That's I didn't know that until just now, so I'm really excited about that part.
And I would say in a similar vein, you know, our commitment around renewable energy, you know, I think at the onset when we were researching the plants, we always sort of said, oh, you know, we'll go electric later. Let's just get the gas-fired plant up and running. But it became imperative to not push off those decisions, and you can blame it on Greta or, you know, just renewed awareness of we can't kick the can down the road any longer. And I think in a similar vein, our commitment around doing our part to integrate the messaging and commitment around helping issues of social justice is also part and parcel of who we are. So very early on, we committed to working with an organization called Working Fields here in Vermont that places formerly incarcerated addicted individuals into positions here at Glavel. And we're also going to work with Vermont Works for Women that also helps women in transition in their careers and in their lives, as well as trying to place new Americans into positions in our organization. So a deep commitment to social justice on top of everything else. So we tick a lot of boxes.
And workforce training. I mean, right now I'm running the apprenticeship program subcommittee for the Vermont Home Builders and Remodelers Association, and we're looking at three things. We're looking at where do we get people. We're looking at what do they need to be trained on, and how do we get that training done. And we look at where do these people work once we have them trained. The kind of the three parts of that particular stream, and all of the Working Fields and Vermont Works for Women, and looking at the resettlement programs here in Vermont for making sure that these underrepresented populations are given an opportunity. How many people are you going to have working at the factory?
Yeah, the factory will be right around 13 to 15 employees. It's not particularly labor intensive, but it is a 24/7 operation. So
3 shifts at 8 hours and the whole thing. Okay.
Yeah.
Okay. I certainly would love to get a tour when you're ready for it.
Oh yeah, absolutely. And like I said, we hope to be announcing, we're calling kind of our demo days when we have a couple of extra bags of product available to invite folks out over 2-3 days to come out and really experience the product, see how it compacts, how it behaves. We have, with early adopters, we've gotten quite a bit of feedback in terms of what it's like to, compact this Glavel that arrives has to be compacted by about 1/3. And, it's so lightweight, it doesn't really behave like 3/8 or any other stone.
Yeah, it's more like pumice when you're done.
It kind of, it floats and it just does take a little bit of getting used to. So we want to make sure that we remove any acceptance barriers if we can by inviting folks out to try the product out, that sort of thing.
I'm super excited about exposing the members of the Home Builders Association to this product, and hopefully we also have early adopters within the association. There are people who are like, yes, Gutex, yes, Glavel, yes, all of these new products. And so we'll have to make sure we tick those people, and hopefully they'll be able to move away from using foam and using this. I did see you sent over some great documentation, which will be available on the links under this YouTube video when we finally get it up. But they include pamphlets, and one of your pamphlets shows where do I use Glavel and how do I use it, and one of them was straightforward under a slab kind of situation, and the other one was as kind of a drainable fill to the outside of the wall above, outside of your wall above your drainage plane and your perimeter drain. So
exactly, and those are kind of the more straightforward applications. If anyone wants to put the foam glass underneath a footing, we do bring in engineers from Europe just to review what the expected compression strength is and what the load is going to be. Arthur at Duncan Wazinski was a very early adopter. I guess it was 2018.
Yeah, that was his house over on.
Yeah, exactly.
Yeah.
So he used
Arthur
it under
Chuckman. I just wanted to make sure we got the full name out there.
Yeah, thank you.
Yeah.
Under the footing at his amazing addition that he did here in Burlington. I should also mention you touched on concrete. Myself and Russ from Engineering Ventures, we did a panel at Passive House, Maine. And Russ is very excited about the applications of foam glass gravel and the ability, because of its compressive strength, to minimize the use of concrete. So if design called for, say, 6 inches of concrete on foam board that has a compressive strength of 40 or 50, because foam glass gravel has a compressive strength of over 100 pounds per square inch, the ability to remove some of the concrete needed is an exciting proposition.
So you're saying a thinner slab would be needed under those conditions. Okay.
Yeah. And, new frameworks we've even seen where, a typical 6-inch stem wall, they did a project recently that they had Glavel under the slab, but they were, doing a 4-inch stem wall. So again, just being, questioning kind of the rule of thumb. That's how you always do it. That's what the forms are. The forms are 6 inches. So we pour 6 inches of concrete. Everyone's really starting to question what's always just sort of been a rule of thumb,
right,
when you're looking at all of these designs and details through the lens of minimizing the embodied carbon.
I'd love to see, oftentimes, just like when we went to a 2x6 wall, there's no change in the structural ability of a 2x4 wall to hold up a 2 or 3 story house, 16 on center, 24 on center, advanced framing, all of these things that we're trying to do to get more out of our resources and have less embodied energy in the materials we're building with. Those are all goals that everyone would agree to, although everybody will have a different opinion about the adoptability and when to adopt that. We're now in a place, oddly enough, with the new RV's code, where it makes more sense to build with a 2x4 wall and do an amount of rigid insulation on the outside to get to that R25 wall, because of the building science of the first condensing layer. You have a 2x6 wall, you need half of that to be rigid on the outside, so you have an R23. You have to do R23 outside to make sure it's going to survive. Well, let's just build a 2x4 wall, so that's an R13. Double that R on the outside, and we're at an R26, which is above code by a little bit at this point. But yes, the same type of adaptation. Or adoption, not adaptation.
Yeah.
I'm making
have
up words as we go.
Have you seen presentations by Chris Magwood and Ace McCardle on how well they articulate the embodied carbon question and how, with a little bit of homework, being able to make dramatic impacts on the embodied carbon. I highly recommend.
So, to be honest, both Ace and Jacob are on my list. I don't know which one of them I want to have on.
I would have
of
them both on at the same time.
They're great. I've been a follower, a friend, and an advocate for new frameworks for a very long time. So I'm definitely going to be taking them to talk about a number of different things. I'm not just the embodied energy, because I think, and the CO2 sequestration that sequestration that they're talking about, I think is a very important point. Jacob is a part of the most recent advisory board on the newest code. We're having deep discussions, and he's trying to bring in embodied energy. This is the second round where he's bringing it up, and
that's great.
And there's traction now, not for making it required, but the new code has a point system. You have base, and you have to add points. We're thinking about incorporating points to allow for that ability to take points or add points to your goal of hitting your minimum code by looking at embodied energy, which is brand new for us as a state, and probably brand new for the country in a lot of ways. And in that way, Vermont can be a leader again.
Yeah, I highly recommend folks playing around with the EC3 platform. So I guess it was fall of 2019. The partnership between Microsoft and Skanska, they put some money into creating a platform where the aggregation of all the EPD reports for materials that were fairly standard. They created this massive database where you can go in and play with, here's my detail, this is what it's calling for, and it spits out the embodied carbon of that detail, and then you can start tweaking it. What if I switch to rock wool, or, make some changes? How does that impact the embodied carbon? It's an amazingly simple and powerful tool to use.
It's also a hard sell with a lot of builders, because builders are not there at counting embodied energy. This is really what we call bleeding edge stuff. But it's important to have the bleeding edge so that it becomes the leading edge, and then can become easily adoptable.
Yeah, and that's what's sort of fun about Glavel is, because it isn't a cost premium, because it's a easier product to install, they get the benefit of the embodied carbon story without even trying. They fall backwards into it. Instead of, it being the leading thing, they by default get all that benefit without even asking for it.
So let's just talk a little about the actual building science information about this. You already mentioned the compressive strength, which on your documentation is listed as like 118 pounds per square inch.
That's correct. Yeah.
If I remember correctly. What's the R value? Because a lot of people are going to say, look, I'm used to putting an R5 product on. That's 2 inches of R5 or 3 inches. That gets me there. What's the R value per inch of compacted Glavel?
Yeah, the installed R value is 1.7 per inch, and we plan on sticking with that R value until we have our domestic production up and running, and we hope to be inching that R value up, by say Earth Day of next year. But yes, it's about our 1.7 per inch installed. The loose, if you were to just install the Glavel on the outside of the frost wall without compacting it, it's about 1.3 per inch.
Okay. Yep. And as with any insulation, you're actually insulating with trapped air, right? That's in the end what we're doing. Yeah,
both trapped air inside of the
and between
each piece, and then in between, exactly.
Right. Interstitial and internal.
Exactly. Right. Yeah. So if you're doing very detailed energy modeling and you have very specific targets, being aware of water table. So is there going to be times of the year where that R value is going to be hindered because of the water table? Factoring that into the amount of insulation that you install is important. What I point to is a lot of anecdotal evidence about the the diminishing returns of foam board over time.
You're reading my mind. I was about to say what happens
Yeah.
to XPS when it's submerged for 2 years.
Yeah, I mean,
Yeah.
we have so many, pictures of ants living in XPS and EPS. We know it gets soggy. We know that we sort of bury it and forget it and say, oh, we built an energy model off of that, but how does it actually perform?
Yeah.
So yeah, I would love, this one of the studies I'd love to see is, looking at the performance of slab on grade foam board over time to see what kind of R value it's really achieving. But just again, anecdotally, we have to believe that it's going to degrade over time. Whereas insects, rodents aren't going to live in foam glass, and it's not going to break down over time.
Right. It is itself not a food stuff. It's not a right. I remember when I was first doing woofy analysis, and they're saying the absorption of fiberglass is 0 because glass has an absorption of 0, and I'm like, no, I'm sorry. I pull out sopping wet fiberglass from cavities all the time. It's not the glass that I'm worried about. It's the interstitial spaces that traps the gas that we're using to insulate. That's the problem. So I'm 100% with you. We're constantly looking for good information about the degradation of a rigid foam insulation that does not have good drainage or a dimple mat, and you can keep it dryish, right?
Yeah.
So you can do a lot of things to keep an XPS or an EPS in good shape. I don't see that in the field. When I'm doing audits, I do not see people installing dimple mats and drainage planes to make sure that
all that gets valued engineered out.
That's right. Well, or the people who did it didn't know it and they needed it to begin with, which is more often the case. Oh, the code says 3 inches of XPS. Let's get the blue board, put it on, backfill against it, and we're done and we're good. That's another nice thing about Glavel is that we should not see a degradation due to off gassing, right? No. All of these EPS, XPS, and other foam board insulations off gas and lose their ability to do the work that they were designed to do over years, and that won't happen with this product as far as I can
exactly
tell.
Right. Yeah. And when we've got cases, things like radon, so foam glass gravel, you can actually run your radon piping through the foam glass, no problem. If you are doing a high performance building and you are really concerned about the true R value and the performance of the R value below the slab, we have had questions, and we worked with Andrew Webster very early on. We had a question about active radon measures. So if you're actively drawing air through a radon measure, that will diminish the R value for a certain square footage around the pipe. So again, if somebody is high performance building and they are putting an active radon measure in, the recommendation would be, let's just sort of calculate, how long is the radon pipe and how much R value do we have to make up? We again kind of use a rule of thumb that the equivalent would be if that Glavel was wet. So we bring it down to R-1.3, which I think is really, really conservative. But again, these are, high performance builders who've done all the different modeling, and we want to make sure that they get the R value they're expecting over time. So,
which is not what I'm getting when I talk to Owens Corning about their pink board. They're not worried about that at all. They're like, okay, the R value tested at 74 degrees Fahrenheit is this.
Fine.
We're good.
Exactly.
That's one of the things about the hegemony of an existing product, right? It is assumed to be already tested and up, down, and left and right. And when you bring in a new product, they'll be asking you questions that these other products were never asked to answer. Like the uptake of moisture in a below grade EPS or XPS. The off-gassing question, the difference in temperature of R value depending on temperature, like we know with polyiso, how it goes down as the temperature goes down.
Yeah, and it is a funny, thing too, because you are literally burying it and forgetting it, right?
Yep.
You just sort of bury it and assume it's going to do what it said it would do, and no one's ever complained about it before, so it
I
must
get
be
that
doing
all the time. No
something.
one's ever complained. I'm like, have you gone back and looked? No. Well,
Yeah.
a homeowner is not going to complain. A homeowner
No.
doesn't have that. As I've said before, the homeowner assumes that the builder is the adult in the room. This is the person who has the information.
Exactly.
And
Yeah.
if I am questioning that, I need to have a basis of information, of knowledge, which is really what House Calls Vermont is all about. We're really about letting the consumer start to understand the building science so they can make
Yeah.
intelligent questions and bring up concerns to a builder that a builder may not themselves know in a state like
Exactly.
Vermont, where they're not required to know anything.
Yep.
Kind of. Well, Rob, that's kind of all the time we have for this. Thank you so much.
Yeah. Thanks for having us. And if people have projects, our typical process for walking them through converting from foam board to foam glass gravel is, starting with the details. What are they traditionally looking at doing? And then we can help navigate them towards foam glass gravel as a replacement.
Can you just give a shout out? I think it's glavel.com, but I don't want to.
Yeah, exactly. Just glavel.com. And there you can,
and
put in
that's
your project
Glavel behind me
request.
here, so you can just look at the name.
There you go.
Glavel. Rob Conboy from Glavel Incorporated here, being built and manufactured here in Essex, Vermont, a local product. I couldn't be happier that you're getting so close to actually having the factory up and running. It's taken, what are we talking now, 4 years that you've been working on getting this together?
I first was introduced to foam glass gravel in Darmstadt, Germany in 2016. So over 5 years from introduction to actually having a plant up and running. But who's counting?
Yeah, well, yeah. You have children, and if I remember correctly, small children still. I think your youngest child is 7 or so now.
Yeah, exactly. Owen turns 6 in December.
Oh, there you go.
Liam is now driving, so that's terrifying.
As are my kids, all of them. Scary. Well, Rob, thank you so much again for taking time out. And when the factory's up and running, I want a live tour of it that we'll broadcast over the airwaves here too.
That sounds great. Thanks, Chris. Appreciate it.
Thank you very much. You're very welcome. Have a great day. So this is Chris West from House Calls Vermont, and if you have questions about Glavel, questions about details, please feel free to shoot us an email at housecallsvt@gmail.com. And you remember, you can always call in during our show times. That's Tuesday evenings from 7 to 8:30 p.m. on our YouTube channel. Just type in on a Google search YouTube House Calls Vermont and you'll bring it up. And the number there is 802-200-2550. If you want to call in with your question, we'd be happy to answer it. Thank you very much. And until next time, this is Chris West.